There is some truth there. All right. So today we're going to look at angles of elevation and depression. Okay. Now. So since you were talking about depression a moment ago, so what is a synonym or another way to say that someone is depressed?
I'm sad.
They're sad. That would be another way.
Low.
Feeling down.
Feeling down or low.
Low brain cell count? It's definitely.
So if something is lower than something else, it is depressed.
So depressed means going down.
Are you depressed?
Indeed it does.
Higher than you?
All right, shh.
I'm a average height.
As opposed to angles of elevation, if you elevate something, what do?
Make them go up.
You raise it up. Okay? If someone's standing on an elevated platform, it's up higher than everything else. That is also why it's called an elevator.
Why is it
Also
called
be
a
a
depressionator?
Because its primary use is to get things up. Getting things down is pretty easy. You just open the window and chuck them out. But getting things up requires work. Okay?
There's a person.
Yes, there is.
Is
This
this
is
still,
trigonometry? Yes.
Is that the person's eyesight?
Yes.
okay.
We'll get to that in just a second. This is one of my favorite lessons because I get to draw really horrible stick figures for absolutely everything.
I think that they're amazing stick figures.
Why, thank you.
They're a lot better than
So an angle of elevation is formed by a horizontal line and a line of sight that is above the horizontal. Elevate, raise up. So if you're looking straight ahead and then it's like, oh, there's a plane, you elevate where you're looking. Yeah. As opposed to an angle of depression, from where you're sitting, you could, like if you looked at something in front of you on the floor, you're looking down, right? That's an angle of depression. So the horizontal is always one of the sides, and then your line of sight is the other side. Okay? So, yes?
If you were staring straight forward, would they be parallel?
Wait a minute, you're staring straight forward. There is no they.
Would my eyesight be parallel for the horizontal and the...
You're staring straight ahead. That's all there is. What other thing are you talking about?
I thought you said that there was a horizontal
And then a line of sight. If you're staring straight ahead, the horizontal and your line of sight are the same.
There's no like that.
If you're staring straight ahead, that is horizontal.
Oh, I get it.
So you...
Yes. That's one thing.
Why can't you be like... in every...
Because you don't have eyes both at the top and the bottom of your face.
Why not?
That's like a spider.
Because God didn't make us that way? I don't know.
Eyes.
All right. So, in any given problem, the angle of elevation or depression depends on the position of the observer. So, in this one, if you're up here on top of this building or whatever the heck it is, and you're looking at someone on the ground, that makes an angle of depression. If you're down here on the ground and you're looking up at this other person, that's an angle of elevation.
That's
So-
why it's named E and D.
Yes. And what kind of angles are those?
Acute angles.
Big one.
They're acute. What else? They're alternate interior angles. And the two horizontals are parallel to each other.
Oh my god.
So the angle of depression and the angle of elevation are always going to be congruent.
Oh my gosh, that's crazy.
So it just depends on who's telling the story, the person on the ground or the person up in the air.
I'd say
In the air.
All right. So let's
How
do
does
some
that person get up there?
an elevator.
Oh.
And if they're depressed,
All right. So while walking in downtown Houston, James spots a dove on top of a building at an angle of elevation of 67 degrees.
That's true. Mr. Davis would probably do that. He'd be like, oh, we are looking approximately 39.
Well, actually, I have a drawer full of things that will measure that angle.
Oh my gosh, guys.
that you will actually get to use hopefully the day before spring break.
Hopefully. Is that the right word?
Well, if you don't want to, we can always do, a new lesson and homework out of the book over spring break. Those are your choices.
Is it like a
Hard
protractor?
pass.
It's kind of like that,
Oh,
yeah.
is it the one with the thing that moves up and down, and it's like one line, and then there's two, but then there's a little thing in
No.
in your mouth.
I don't know what she's talking about, but I'm going to say no. So we always need a sketch for this, and you always need a horizontal. For these problems, we will assume that the ground is level and flat, which in Houston is not a bad assumption for the most part. Okay? So we need James. It doesn't matter whether you put him on the left or the right.
Right. Because right-handers are better.
Okay. So here's James. Doo-doo.
James is kind of a boring name.
Kind of a what?
Boring
That
name?
might be someone he knows. Most of them are.
It's my son.
I knew it.
I was talking about a different James.
I was talking about a different James.
Oh my god.
All right. And then we need a building somewhere away from him.
I really did this with the wrong Caucasian.
Yes, you did. With a dove on it. Like some 3-year-old draws seagulls.
15-year-old.
Now, for simplicity's sake on these problems, we will not take into account the fact that his eyes are not on the ground. Okay? We will, when we go outside to measure things on that Friday before spring break, we will do that in our calculations. We're going to find some things that are too tall for us to climb up on and to measure. We're going to try to measure them indirectly. Just like here, he's not going to climb up the building to measure how high the dove is off the ground. Yes, ma'am.
Can I put a mohawk on James?
You can do whatever you like with James. All right. So the angle of elevation is 67 degrees. So from the dove down to James, this angle, 67 degrees.
Do we have to also draw the horizontal line or no?
The ground is the horizontal line.
Oh, I thought there was another one above the line too.
If we were taking into account how high his eyes are off the ground, there would be.
Okay.
But we will not for simplicity's sake. He is 100 feet from the base of the building. So here is the base of the building. That distance is 100 feet.
Oh my gosh, it's gonna be a fraction.
How high is the dove off the ground? So I'm going to call this distance D for dove because I'm not boring and make everything X and Y. So from the 67, the 100 is which side?
Adjacent.
Adjacent. And D is?
Opposite.
So that means?
Tangent.
Tangent. The tangent of 67 degrees is equal to D over 100. So D is, yes, you will, 100 tangent 67. Yes, ma'am.
Oh man. What is it called again?
What is what?
The tangent. I don't want to say it. You said not to say it.
Tangent inverse?
Yeah. Never mind.
No, why wouldn't it be tangent inverse?
Okay. Am I trying to get this angle by itself? No. That's why it won't be tangent inverse.
Okay.
We use tangent inverse to get rid of tangent when we want to find the angle.
Okay.
So the dove is approximately 230, we'll call it 236 feet. Did it say what to round it to?
Nope.
So since his distance was given in feet, we'll give this to the nearest foot. Your homework. Oh my goodness. Yes, you may. Okay? Any questions about that one?
No, sir.
Okay, let's look at another one.
Is Kira your daughter's name?
It is.
I remember that.
I like her hair. She has really pretty hair.
Don't say anything about the thing.
I actually used to, whenever I was little, and I used to play like family or whatever, I would always name my daughter Kira,
Really?
but I spelled it really weird.
I would always make myself Crystal.
Kiera?
No, Kira.
That's not really weird.
That's that.
All right, so in a battle simulation,
Oh my gosh.
Kira stands on a castle's parapet 12 meters above the ground.
What's a parapet?
Okay, is it important that you know? No, it's not.
Draw a box.
Yeah.
Is it like a tower thing? Like a...
The parapet is have you ever seen the ones where people are shooting from the top of the castle?
Like
And it
an
has like
Alamo?
Okay.
little block things. So you
Yes,
can-
where you can stand in between them to shoot or hide behind them.
Those
the
are so
wall-
cool.
The wall that they're standing on is called a parapet.
Like the Alamo, around the Alamo where they had the, like.
Yes, similar to that.
Okay.
All right. So she's 12 meters off the ground. So I need the ground. Again, we'll assume that the ground is level and flat. I need something to stand for what she's standing on. I just draw a rectangle. And then I need her on top of this.
That's really tall. Yeah, I'd be scared if I was that high off of the ground.
It's a good thing you're short. It has nothing to do with that.
Is it hair?
Okay.
She should be like a hair model.
So she sees an enemy spy at an angle of depression of 35 degrees.
No.
So the spy is on the ground.
Make him into like a ninja guy. With a machete.
Machete.
What's that?
He's got the
head.
mask with the thing sticking out on the back.
Why do we have two different winds? Like one's pushing this way, one's pushing this way.
There could be a fan.
Or maybe she's just having a bad hair day.
She's having a great hair day.
In order to hit the spy with an arrow, she needs a bow and arrow.
This person is so cool.
I know, right?
How far must the arrow travel? And how far is the spy from the base of the parapet? All right, so we know that this is 12 meters.
Are we gonna?
And there's an angle of depression of 35 degrees. That means if she was to look straight forward, so at a horizontal, and then look down, that this angle would be 35 degrees. The most common mistake made on angle of depression problems is because you have to draw in the horizontal, people want to put it here, between the vertical and the line of sight. It's always between the horizontal and the line of sight. Okay? So we want to know two things. We want to know how far does the arrow have to travel? So I'm going to call this A. And how far is the spy from the base of the parapet? I'm going to call this S. We'll also assume that any buildings stand perpendicular to the ground. And at this point, you may go, well, I don't have any angles inside this triangle. But remember that the angle of depression, yes?
Is it 90 minus 35?
We could find this one, or without doing any subtraction, we could say, well, the angle of elevation from the spy to where Kira is also 35 degrees.
And then you know the third angle.
Yes, or we could just do like Savannah was saying, take 90 minus 35, and that would be 55 for this.
Because you have three.
You mean we have 2 out of the 3 angles?
Yeah.
Okay, so to find the arrow, from this 35, 12 is opposite, and A is the hypotenuse, so that means I'm going to use
Sun.
sine.
Oh, yeah.
So sine of 35 is equal to 12 over A, which means A is equal to 12 times the sine of 35.
12?
Because this is 12 meters. That was given.
I mean, why is the 12 in the top triangle? How is it in
I'm looking at this triangle.
the... Oh, sorry. Never mind.
If you want to, you could draw this in and say that it's 12 also
Oh, okay.
to complete the rectangle.
Oh, okay, I understand now.
Yes, ma'am.
How did you get from your first equation your sine 35 equals 12 over 8 to 8?
Same way I did on yesterday when I talked to you about this.
Oh, okay.
I did a over 1 equals 12. 12 over the sine of 35.
Okay.
That makes sense?
Yeah.
Okay. So I'm going to take 12 divided by the sine of 35. So it's going to have to travel 21 meters.
The arrow?
Yes. Seems reasonable to round it to the nearest meter. Yes.
Could you not multiply by a and then minus sine 35? Or no?
Divide. Because it would be a
Oh,
times the
I'm
sine of
trying to-
35. Right.
Oh, so you'd have to
And then you'd have to
by the
divide by the sine of 35. Yes.
Oh, okay.
And you end up with the same thing.
Mhm.
We had this same conversation yesterday. Okay? All right, and then for S, from the 35, that's adjacent, and 12 is opposite, so that's tangent. So tangent of 35 is equal to 12 over S. So S is equal to 12 over the tangent of 35. So as I showed you yesterday, if you do second enter, you can just change that sign to tangent, or you can type it all in. It's not that much typing. So I get S is 17 meters.
My tower looks like a fork.
Yes, ma'am.
May I go to the restroom, please?
Yes.
Okay, thanks.
Although I don't think you really want to miss this next one because it's a lot harder.
Okay, I'll stay.
All right.
Is this your wife's name?
It is.
That's fancy.
We don't like all your family's names from all your math problems.
Yes. So Tristan is standing in a lighthouse 68 feet above the water. She sights two boats in the water directly in front of her. The angle of depression to the nearest boat is 48 degrees, and the angle of depression to the other boat is 22 degrees. What is the distance between the two boats? So, again, we always need ground level. We will assume that the sea is glassy smooth this day. And she's over here. And she's 68 feet above the water. And there are two boats in the water directly in front of her. Okay. So I need a stick boat. Little stick sailboats. The angle of depression to the nearest boat is 48 degrees, which means that the angle of elevation from the boat to her is 48 degrees. And then the angle of elevation to the other boat is 22 degrees. And we want to find the distance between the two boats.
Do we have to make that middle bit into a triangle? Like we calculated that triangle?
The middle bit.
From her to the first boat to the second boat, that triangle.
That is a triangle.
Are we going to
No, because it's not a right triangle. Now, when you get to pre-cal, you'll learn a way around this. But for now, what we're going to do is we're just going to do two different problems. What we're going to do is we're going to find this distance, the distance to the far boat, and then we're going to find this distance, the distance to the near boat, and take the difference between those to find the distance between these two boats. So we're going to do two completely separate triangles.
And then subtract them.
Right. So let's start with the big triangle. For the big triangle, try and ignore all this stuff in the middle. F is one of the sides. Which side is that to the 22? Adjacent, and 68 is?
Opposite.
So that's going to be
Tangent.
tangent. So the tangent of 22 is going to be 68 over F, which means that F is going to be 68 over the tangent of 22, and no, I will not bother calculating that right now. I only calculate stuff at the very end. And then for the little triangle, from the 48, N is which side? Adjacent, and 68 is?
Opposite.
So that's still tangent. So tangent of 48 is equal to 68 over N. So N is 68 over the tangent of 48. And what I really want, which is the distance between them, is F minus N. So that's 68 tangent of 22 minus 68 tangent of 48. And that's the kind of thing your calculator is really kind of built for.
How do we do a fraction on a calculator?
If you really want to do a fraction, you can. If you do alpha, y equals, the very first option allows you to do a fraction. You're welcome. So 68 over the tangent of 22 minus, or you can just do 68 divided by the tangent of 48. It works out the same way. And we get the distance between them is approximately 107 feet. Yes, Savannah?
I did it where I did them individually and I still got 107. Will it always be the same?
What do you mean you did? Rather than having to do a calculation and then do another calculation and then do a third calculation, I just do it all at once.
Okay, but if we do them separate,
That's fine, just don't round anything.
okay. So we have to use the exact number because it might be like 1 point different. Or something.
Right,
Okay.
right. It might be slightly off.
Yeah.
Yeah, the basic rule in math is never round in the middle of a problem. You only round at the very end unless there's no other way around it.
Yeah.
Get it? No other way around it.
Oh my gosh.
All right, your assignment is again in the book.